Hello and welcome. I am Vishwanathan. In this video, let us try to learn and understand the second lab program of Artificial Intelligence and Machine Learning Laboratory of VTU. The program is titled AOStar. Now let us get a brief introduction about the algorithm, that is AOStar search algorithm. Now AO can be expanded or can be understood as AND or graphs. So it is basically a divide and solve approach. So you can see a basic example here. Now there is one convention which we need to understand. Now this is assume that this is the root node or the start node, and these are the children. This is one particular path from the start node to this particular node, and here you see something like an arc between these two links. Whenever you see an arc, it means that it is an AND representation. So when we are calculating the cost of this particular path, then we need to consider both the nodes, that is both the links to which the AND is marked. So this is the basic idea of AOStar graph or AOStar search algorithm. Now this is the formula or the concept which we study in theory. So f of n is the cost or the cost of the path from the start to goal. G of n is from start to current, and h of n is the heuristic value, or we can assume the cost from that particular node to the goal node. So it is from start to goal f of n, g of n is from start to current node, and h of n is current to goal node. Now the algorithm itself is actually so simple, but the implementation is not that very easy. Anyway, the basic algorithm says like this: from the start node, find the best path. So from the start node, find the best path. From the chosen node, that is in the best path, that is what we get the chosen node or the best node, we in a way repeat the same thing. So again find the best node. So this is the basic example we have chosen. If we consider this, so this is the start node. From these three we will get one of the best node, that is we will get the chosen node, that is it can be either this, because there is an AND curve and representation here. It can be this BC, A to BC, or it can be A to D. Anyway, so from the chosen node, again we have to find the best path. Suppose the best node is D, then again we have to find the best node among its children. So we get the clue that it is a recursive function, and whenever we find the best node, we have to update its h value. Now what is h value? Even in A star algorithm, I use the same notation. Next to a node, whatever value is written in the box, that is the heuristic value. So it is like the estimate or the approximate cost from that particular node to reach the goal node. That is represented in box here, and this is the problem we are solving in this program. So between the link between every two node has the cost 1. It may not be represented. It can be given in the problem statement itself. So this is the assumption, and whatever is written in the box is the heuristic value. It may not always be written in the box. Just for easier representation, I have chosen this notation. Now, as I said, when we are finding the best path, so what we do is we update the h value of that node. Suppose we find the best path over here. The h value of its parent node is updated. Then again h value of its parent node is updated. So we get the clue, or we get the term backpropagation here, or we can also call it we are traveling backwards, or we are updating the h value by going back. Okay. Now this is something which we need to understand. So in some problems, for some particular nodes, the h value will already be given as 0. Then wherever you see the h value as 0, that means it is like the goal state, or it is the goal node, and we can label it as solved. In other problems, for example this, for none of the nodes there is a h value 0. But when when we are going in a path, when a particular node has no children, then that node's h value can be made 0, and that is considered to be solved. Now, when E and F both are solved, because there is an anchor here, when E and F both are solved, we can update that D is solved. And since there is no anchor here, so it is an independent path, when D is solved, we can label A is solved. Again here, when either G or H is solved, we can label B as solved, and when C is solved and both B and C is solved, we can update A is solved. So this is the basic introduction. Now that was all in this particular diagram, so this may not be required no more. Okay, now this is the problem we are solving. Let us get into the problem, that is the program. Here we can see we are creating one dictionary. H2 is a dictionary basically, and the same notation is more or less followed in A star also. Now we can see that H2 is a dictionary and there are key value pairs. So A is a key which is a node, and what does 1 represent here? 1 is the heuristic value. So H2 you can call it the heuristic dictionary as well. So what we are doing here is we are just creating a dictionary in which each key is a node and each value is a heuristic value. So this is self-explanatory. You can understand that, for example, for the node H, the heuristic value is 7. Next, what we are doing here is graph 2 is also a dictionary. You can wherever you see this curly brace, it is a dictionary. So in graph 2 dictionary, what we are trying to represent is from A what are the children and what are its associated costs. So this I have already explained. So A is having basically it has got 3 children, B, C and D, but since there is an AND representation here, there is an AND arc here, B and C must be together processed as a single list. So you can observe here that there is one list in which B and C are the items of the list. So reaching B is having cost 1, reaching C is having cost 1, but they together makes one particular path or one particular child, and D by itself is a separate list. Again, from B has got G and H, we can observe here that G itself is independent, H itself is independent. When for the case of D, D is having E and F, but you can see an AND curve here, so there is one outermost list, that which means to say that D has got E and F as children, but they have to be considered as 1 because there is an AND arc here. Now H2 and G2 is understood. After this, what we are doing here is G2 is equals to graph of, then we are passing this graph dictionary, we are passing H2 dictionary, and we are passing one particular node A. Now what we are trying to do here is we are creating an object G2 of the type class. So the class can be seen on top of the program here. So class graph is having a few the class called graph is having a few members. So these are the class members, these are all the class member functions, so these are the member variables. So we can see that whatever is passed, so self is like a inherent pointer. Python doesn't actually have pointers, but it is analogous to this operator in C++ or Java. So anyway, self is like the object which we are referring to, and graph is the first parameter. The first parameter we are passing here is graph 2, that is this graph that is represented where we have represented the neighbors or the children. So that is the first parameter. H2 is the heuristic value parameter. Third one is the one particular node, which will actually be the start node. So the 3 parameters are understood. We are just initializing. Self.graph is equals to graph, then self.h is equals to heuristic node list. As I said, heuristic node list represents the items in the values in the box, and start node is what we have passed as a third parameter, which is A here. So we are just creating this particular class members. Graph H, start node is start. So these 3 is self-explanatory. Self.parent, self.status and solution graph, these becomes relevant only for the solution graph. That means to say initially this will be an empty dictionary. Parent, status and solution graph, they are empty dictionary, they have to be initialized. The type of the class member is dictionary. Now basic members are understood. Init is the inbuilt function which it will take the it is like the constructor function. It will take the parameters whichever we have passed, and it will create the object with the members assigned to whatever is there in the parameter list. Okay, now we have a few class functions, that is member functions. This is not this function may be considered in general as well. It can be written outside as well, but anyway we have written it as a class function itself. apply AO star. So this will be executed only once. So for the start node self.start, we just call this function apply AO star. It will just call this function AO star, which we have coded here. We will see it later. It will call the AO star function for the start node. False is the parameter of the that is the second parameter. We will understand once we come there. So this function is just, you can understand that it is starting the recursive AO star algorithm. So this happens only once. Next, we can memorize the program. Like there are 4 functions here: get status, set status, get heuristic, set heuristic, and there is one function called get neighbors. So this is self-explanatory. Get neighbors will return the neighbors of a given node. So for a given node V, it will return self.graph.get of V. Now what is graph? Graph is the dictionary which we have passed from the main function or the main part of the code. So it will return graph.get. What is get? Get is an inbuilt function which is applicable to dictionaries. It will return the value for this particular key. Key is V here. For whichever node V we have passed, it will return the value. And what is V comma this empty thing, empty list or empty string basically. Get has this advantage that if a particular node is existing, if a particular key is existing, it will return the value. But if it is not existing, it will return the second parameter as the default parameter. If this V or this key is not existing in the dictionary, it will return the second parameter as the return value of this get function. That is the understanding. So it will just get the neighbors of a particular node. Get status is also self-explanatory. The meaning of status, parent and solution graph is still not relevant because it becomes meaningful only when we are starting the AO star algorithm. That is when we are building the solution graph. Anyway, get status will just return this status of that particular node, and the set status here, it is understood that when we need to set the status, we need one additional parameter. So get status will have this will be the same, self comma V will be retained in set status as well, but it will take an additional value, additional parameter called val, which will be this value that is to be set. Again, get heuristic node value. This is also self-explanatory. It will return the heuristic value of the particular node n, and if that node is not existing, it will return 0. That is the meaning of this get function. Set heuristic node value, again it will be the same as get heuristic node value with an additional parameter called value, which will be initialized. Now the class graph is understood. Now basically for print solution is a very simple function. It is just required to print the solution graph. So we just print a statement called for graph solution traverse the graph from start node, and we print the start node, and we just print the solution graph. So this is a very basic line of code. It needs no further explanation. The main computational part of this AO star algorithm is carried out in these 2 functions. That is, one is compute minimum cost child nodes, and the main algorithm itself, AO star. Now before trying to code this part of the code, it is better to have a basic understanding of how the AO star algorithm works. It is a problem in theory as well. Anyway, we will just understand how it works. Now as I said in the other diagram, it explained that it is basically a recursive approach and there is backpropagation, so that we need to remember. So from the start node is A here. So I have solved the problem by hand. So this will be better to understand the AO star algorithm itself. After that, the coding these 2 functions will get relatively easier. Now initially we are in the start node, so node considered is A, and we are exploring the children. So F from I have written A arrow mark B comma C. I have combined B comma C because there is an AND curve here. So to reach this B comma C, it is the heuristic value of B plus the weight to reach A to B. So this is 6 plus 1, and the same applies for C also. 12 plus 1 value is 20, and for D it is 10 plus 1, that is 11. So from these 2 we consider the node D, because in the basic algorithm it says that we have to choose the best path. Best path is the lowest cost. So node considered is D. Now, initially this was what is given by the problem itself. This diagram may be written on the board, or it may be represented in other ways also. Diagram may not be written, but H values and the this particular thing H and G has to be given. This cannot be. It can be. It cannot be written on own, or maybe this is one simple problem which we can memorize. The problem looks simple. Otherwise, this will usually be written on the board. Anyway, so now we have considered from A, we have got that the best path is D. So now we are considering the node D. As I said, this IO star algorithm has what we call as backpropagation, or we update the H value of its parent. So now H value of A becomes 11 because this is the node we have observed, or we have calculated this is the best node that is the chosen node in the best path. So the H of A value becomes 11. Now this solution by hand is quite useful because this we can compare it with the output of the program. So initially we are considering the node A. The same is can be seen here as well. Next we are processing the node D, but this is what happens in the background. So it will find that the best node is D, and it will update the value of H of A. So this whatever value is in the box, it becomes 11. So the same can be seen here. It was 1 initially, it became 11. Now to update it, we have gone back to A. That is what is seen here in the third output statement. After that, from D, we are exploring its children. That is, these children are E and F, and there is an anchor here. So next we are considering E. The cost to reach E is 4 plus 1, that is 5. And as I said in the previous diagram, when a node has no children, we can assume that we can update its H value as 0. That is what is seen here. The same is relevant here also. When we are processing the node E has no children, so in the next iteration the H value of E is updated to 0, and when we have updated the value of a child E, then obviously its parent has to be updated too. So H of D now becomes 0 plus 1, 4 plus 1, which evaluates to 6. So you can observe that in the next iteration D value has become 6 and E value has become 0. Now again the backpropagation continues. When the H value of D becomes 6, obviously it will be 6 plus 1, so H value of A will become 7, which can be seen here. Now solution graph was an empty dictionary in all these steps. Since we observe that it has got no more children, we label the H value as 0 and we start. So E has no children, and after we have explored E, the next thing we have to explore is F. So we are processing the node F. Again the same thing happens. Since F has no children, the heuristic value of F gets updated to 0. We can observe here F is processed, and in the very next output we can see that the H value of F is 0. So now the H value of F is 0. Then obviously the parent node has to be updated. H of D will now become, this is 0, this is also 0, only these values become relevant. So 0 plus 1 plus 0 plus 1, which evaluates to 2. We can observe that these heuristic value is also updated to 2. So now what does this mean? In the anchor, E has no children, which means it is H value is 0. In other words, it is solved. F has no children, so F is also solved. When E and F both are solved, that means D is solved. So we can observe here, E has no children, F has no children. In the next step, since these two are solved, we can label this as solved, and we can give the path. So the key called D will have the value as E comma F. When D is solved, it means A is solved. So the path is A to D, D to E comma F. So that is what we have got the output here. And if each of the values in the output is explained here, we can observe that whatever other values, for example, in the curve, in the graph, there are other values too. For example, G, H, B, C. Those values are not at all updated because we are not considering them at all. In the very first step itself, we chose that D is the best path, and even after updating it, it was found to be the best path. So this part of the curve is never explored. So we can observe that those values G, H, and these values they remain constant throughout the working of the algorithm. So finally, we will have the solution like this: E has no children, F has no children, E and F are solved. Because E and F are solved and there is an AND curve, D is also solved. D's children are E and F, and since D is solved and it is independent, E is also solved. So that is the output. Now we have understood how this is working. Let us now understand the major two functions, as I said, compute minimum cost and AO star. Now let us understand AO star function first. When will this AO star be first called? It will be called in this particular line. It is called on the start node. What is the start node? Start node is A, and what is the second parameter? It is false. Now let us understand this function. When this function is called, self is like this, the inherent pointer, or the it is like this object, and these are the two parameters. V is now initially A. Backtracking, the value passed is false, so we can understand that backtracking is like a flag value, or it is like a status value. That is what even is written in the comment here. So it is a boolean value which can either be true or false. That is it. Now when this function is called, this is understood. So we are just printing the heuristic values, we are printing the solution graph, and we are printing the current node or the processing node. So that is done in these 3 lines of code. It is self-explanatory. Next, as I said, there are functions called getStatus, solution self.getStatus. Now, initially getStatus has no meaning because we have still not come up with any solution as such. So when this getStatus of V is called, V value is actually start, that is A here. So getStatus of A, we can observe in the getStatus we are passing the parameter A here, and when the getStatus has no when this getStatus is called, if that value V is not already existing in this status dictionary, which is initially empty, what it will return? It will return the second parameter, that is the inbuilt parameter. So now the self.getStatus of V, which is actually A, will be 0. 0 is greater than 0, so the entire part of the code is working. So once the getStatus is called upon the start node A, only for that usually it will be 0. After that, we can see that once the status is retrieved in the same iteration itself, we are setting the status of that particular node V. So usually this initially will be 0 for the start node, and later on it will be whatever we have updated here. Now once we have got the status of A, which means that which is 0. Now what this status means? Status is like a parameter which tells how many nodes are yet to be explored, something like that. Now initially it will be 0, but actually when we are in A, that means whenever the when this function fails, that is when this condition fails, self.getStatus is greater than equal to 0. That means this has to be something lesser than 0, which is -1. So that happens only when we have come to the solution. So otherwise it will be 0 or whatever the value we have set. Okay. Now we call the function called compute minimum cost child nodes. Now the function name is very self-explanatory. It will compute the minimum cost child nodes. So what does it return? It will return the cost value, and it will return the child nodes list. In other words, now from A, the minimum cost child node is D. So the minimum cost is actually 10 plus 1. So this is the minimum cost, and child node list is D. Had this been the minimum cost, then it would have, this child node list would have B and C as the item. Basically this is a list, child node list, and minimum cost would have been the value of this particular thing. Anyway, now let us understand this compute minimum cost child nodes of V, this function. This function basically will take only one parameter. that is from a given node, what is the minimum cost child node. So the function is not very complex. Initially we assume the minimum cost is 0 and we create an empty dictionary that is also self-explanatory, and we create in this dictionary minimum cost, that is for this value 0, that is the first item in the dictionary. We are just initializing a list, empty list, and we are setting the flag to true. Now these are the 4 initializations. It is easy to remember. What happens next? So basically when we are to find the best minimum cost child node, first of all we need to get the child node. So we are child nodes, in other words, means neighbors. So we just call this function for nodes, this is the variable for node info tuple list in self.getNeighbors of v. So this is the self is the object, that is the graph object, and getNeighbors is the function. So for example, for if the value of v is a, now it will return the neighbors of a. What are the neighbors of a? B and C together as one list, B as a separate list. That is what is happening here. Now get neighbors of v is called, it is already explained here, get neighbors of v. For every item in this, whatever it returns, so we have to find the total cost. So initially we will just assume that the cost is 0, and the node list we need an empty list because it is not yet explored. Once we have got the return value, suppose we are considering this b comma c as a list, what we need to do? We need to explore each item in the neighbors. That is, if a is returning, this get neighbors is returning 2 things, so b comma c and d. So b comma c has to be explored and d has to be explored. So what we do here, for c comma weight in node tuple list, so this is one item. What is c? C is node info tuple list. So node info tuple list, as I said, it is the whatever is written in the get neighbors. Get neighbors. Basically the neighbors is like the node itself and the value associated with it. So this is what we are processing here for c comma weight in node info tuple list. C is the node, it's the node name, that is a node value, and the weight is the cost of reaching from its parent. So for c comma weight in node info tuple list, so we are updating the cost. Initially the cost was now actually the cost is 6. Cost plus what is the heuristic value of c? Now the heuristic value of c was, b was 6 and its cost is 1, that is 6 plus 1 is 7, and we append it to 7. So we just append it to the node list. Next, we are seeing that initially it is anyway initialized to true, so this condition will obviously execute if flag is equals to true. We will just assume that minimum cost is this and cost to child node list dictionary. So this dictionary will be updated. So whatever we have appended here, that is initially it will just be b, it will be appended to this cost to child node of minimum cost. So this dictionary will be updated here, and as soon as this is done, the flag is set to false. So now this earlier value has no meaning now. In the next iteration itself, what it will do, this particular part will not be executed. It will check if the minimum cost is greater than cost. So in other words, so we can understand that when b and c is evaluated, as I said, the value of b and c is actually 20, that is the minimum cost is 20, but the minimum cost what we already find here. So what is the cost of this particular part? It is actually 11. So whatever it is calculated here, that is 20 is obviously greater than 11. So what we do, we just update the value of the cost. So minimum cost is, we update the other cost, and we set the new node list to the dictionary of cost to child node list. So this is basically a long name of it is just the dictionary name. So we just append that particular node. So minimum cost. So what is the minimum cost now? Minimum cost is 11, and the node list will have d. So it will just return. So this total after the entire neighbors are explored, ultimately it will return the minimum cost and cost to child node list of dictionary. So this will come and sit here. So we have understood the function compute minimum cost child nodes. This is understood. So in a way, if we just understand how this AO star is working, we will be done with the program. So self dot compute minimum cost child nodes of V. So this whatever it will return, we have understood. It will return the cost and the minimum child node list. So what is happening here? It will return the cost as 10 plus 1 11, and child node list will have list D, not D itself. It will have a list D. Okay. Now what we do next? We just set the heuristic node value of V comma minimum cost. So now what was V initially? V was initially 1, but since we have got the minimum cost, we will update the heuristic value. That is what is relevant in the output as well. So you can see that it was initially 1, it will be updated to 11. So we just set the heuristic value. And now what is the status value? So initially, as I said, status has no meaning, it is just an empty dictionary. But since we have found a path, now what is the length of the path? It is 1. So now set status of, for this item called V, that is node called V, which evaluates to A. So V here means A. It will just be set to the value of the length of child node list. So what is the length of the child node list? It is 1. So length of the child node list is 1. 1 will be set to the value of the status flag of A. So now this status dictionary has a meaning. So for this particular node, now we will have A. It will be set to the value. Value is nothing but the length of the child node. So anyway, the entire thing what we are doing here is we just set the heuristic value of A and we set the status value of A as 1. So we are done with this particular part of code. Next, we create a variable called salt. Salt is equals to true. And what we do next is, so as I said, once we have found the best path in the algorithm which we already explored, that is here, we already understood this algorithm. So what does the algorithm say? It will say that from the best node from the start node find the best node. So we have come to this particular node. So from the chosen node again find the best node. So this is what is being done here. So from this, so if salt is equals to true, anyway, from we have said the salt value is true. From the child node, for each node in the child node list, what we do is we set the parent node as V, that is parent node will be A here. So parent of child node is B, self dot parent of child node is V. Now this is important because ultimately we are finding a path, or we are finding the how we need to traverse in the graph. So parent dictionary now has got meaning. It says that the parent of B is now A. Next, if self dot get status of child node. Now this child node value initially, as I said, get status default value is 0. So obviously it will not be -1. -1 will be the status value only when there is nothing to explore. So if self dot get status of child node is not equals to -1, obviously here it will not be -1. So this whatever value you assume, that is salt is equals to true, it will become false. So once this is false, what we do, we just when the salt is false, it means that we have still not come to the goal state. That is the meaning. So that is what this part of the code is doing. So this will be executed only in the this will be executed when this condition is not happening. So if we have already reached the goal node, it will not be updated. Otherwise, it will be anyway false itself. So this part will be executed in the last. So let us understand this at the end. Anyway, next now when V is not the self dot start. What I mean to say here is, what is self dot start? Self dot start, as you can see here, is initialized to start node. Start node is A. Now currently the V is currently the value of V is A itself, and it is not equal whenever it is not equals to the start node. So when we are not in the start node, then what we do, we will in a way backtrack. So this is you can see that this is a recursive call. The function name itself is AO star, and we are calling the function again. We are backtracking only when this current node is not the start node. That is what is happening here. Otherwise, Otherwise what we do, obviously this backtracking value will be false. Backtracking is what this final I mean the last parameter, it is by default false. How it is false, we can see here. When it is called for the first time, we are calling for the start node self.start, and the default value for backtracking is false. So in the first iteration, this backtracking will obviously be false. Next, what will it do for child in the child node list? So in the child node list, it will set the status of D as 0. That means it will think that okay, now we have reached here. From this particular point, we have to find the best path. So whatever happened for the start node will happen for this particular node. So it will set this status as 0, and again it will call the AO star algorithm for the child node. Now the child node is D, and this value is false. This is also quite understandable, because when we are calling for the start node, we called it for false. I mean, we call the value for backtracking as false. At this point itself, we have assumed that this is the start node, and we are repeating whatever we did at this point of time. So we will call the backtracking with value as false itself. So when the execution proceeds further, now at some point of time, solve will be true. When will solve be true? We will understand here. When this so if the solve is true, that means the minimum. So for example, when we are in the node E, when we have explored E, obviously it will be solved because there is no children. What we do, we set the status. So this cannot be explored further. That means this is like the, we set the status of that particular node as -1, and we just append whatever is. So the child node list will actually have nothing. So it will just, solution graph will be the previously existing graph. So it will be like A, B, and this is explored. So this status of V is set to -1. Now this part of the code is executed. Similarly, solve will be true when we are exploring F also. So again we will have the status value as -1. And when will this part of the code be executed? Now when we are in D, we need to call the AO star for the parent node. That is, we need to backtrack. When we backtrack, again the AO star algorithm is called from beginning. So AO star is called from beginning. So everything gets printed, and here we are updating the heuristic value. So as you can see here, we are updating the heuristic node value based on whatever this compute minimum cost child node function is returning. So this particular line of code will be executed when V is not the start node. So when it is in D, it will, for anyway, if the graph was even further, somewhere when it was here, this particular line of code would be executed, and its previous, that is its parent node, will be updated. Updation takes place here. Ultimately, this will happen until V becomes the start node itself. So for example, now when we are in node D, self dot parent of V. What is the parent of V? Parent of V is A. Parent of D is A. So when again this execution takes place, but when this particular line is encountered, now what is value of V? It is A itself, and if everything is solved, this part of the code is not executed. So ultimately this will be returned. So we are not returning anything. Every time we just print the heuristic value of all the nodes, we print the solution graph, and we print the currently processing node. So that is what the output says here. Now the execution, as I said, this was explained earlier. H2 is the heuristic dictionary, and graph is the neighbors dictionary. So we are just creating a graph object, that is instance of type class graph, and we are calling the apply AO star algorithm, apply AO star function. Apply AO star will come here. Apply AO star will come here, and it will call the AO star function for the start node. Again, this is never again executed. This AO star itself is recursive. You can see that AO star is recursive. Next, and what does this print solution do? You can see in the final line of output, it is just printing the solution graph, or it is just printing the graph solution. So what this print solution will do here? Print solution, as I said, it is a very simple function. It just prints the solution graph. So solution, where are we creating the solution graph? Solution graph is being created. solution graph initially is an empty dictionary. So in obviously AO star algorithm itself, what we do is we create, we don't create, we in the empty dictionary we just update. So we create one key called v and we create the child node list. We update the child node list as the contents of the v. That is what is happening here ultimately. So initially what this, it was an empty dictionary, the solution graph was an empty dictionary. So we have created the key as e and we have made it as an empty list because it has no further children. Similarly for f, and when we came to d, it has two children, e and f both are solved. So d has d for the key d, it has the value e comma f, and d is solved. When d is solved, a has the child d, so we are creating one key called a and we are creating the child node as d. So this is what the AO star search algorithm is doing. The output is already explained, the function is explained, and the entire flow of execution is also done. So this was all in this video. Thank you.